You are standing under a pool of harsh lamplight, deep in the cavernous hush of an old physics laboratory. Wooden cabinets tower above you, dusty glassware glinting like stars, while chalky equations snake across blackboards on every wall. Somewhere in this silence, you feel the weight of a question so strange it could make your neurons implode. Can particles remember where they've been? And tonight, you're going to wander into the shimmering borderland between certainty and possibility, where the universe seems to whisper secrets about the nature of reality itself. And spoiler alert, you probably won't survive this with your sanity entirely intact. So before you get too comfortable, take a moment to like the video and subscribe a bit, only if you really like what I do here. And hey, tell me in the comments where you're listening from and what time it is right now. Now, turn down the lights, maybe turn on the fan for some soft noise, and let's get started tonight. You look around the laboratory, half expecting Einstein himself to shuffle into the room in a rumpled sweater, hair frazzled as though he's been wrestling a cosmic riddle all morning. And honestly, he probably has. Mainstream fact, Einstein devoted his entire career to revealing the hidden rules of the universe. He gave us relativity, showing how space and time stretch and bend. But even he stumbled when it came to quantum mechanics, a realm where particles seem to know possibilities we haven't even chosen yet. Quirky Einstein tidbit: despite unraveling the cosmos, Einstein once confessed he liked to go sailing but was notoriously bad at it. He'd forget to untie the boat, crash into piers, or simply drift aimlessly. Physicists still argue whether he was searching for simplicity on the water or just distracted by cosmic mysteries. Either way, it's comforting to know the world's most famous genius occasionally forgot where he was going. Hovering in this lab, you feel the hush of suspended dust, as though the entire universe is holding its breath. The question hanging in the air tonight is deceptively simple. When a single particle, like an electron or photon, travels from one place to another, does it carry a memory of its path? Or does it behave as though every possible path remains open, even after it's arrived? Physicists still debate whether the concept of a particle's path even makes sense in quantum mechanics. Some believe particles follow definite, albeit hidden, trajectories we simply can't measure without disturbing them. Others argue that path is an illusion, a classical idea imposed on a reality that doesn't obey classical rules. Einstein's violin peeks out from under a cluttered table, its polished wood glowing faintly. You imagine him lifting it to his chin, drawing a long, mournful note as he contemplates a particle's mysterious journey. Because in Einstein's world, everything should have a cause, a path, a memory. No particle should simply decide where it's been after the fact. Yet the quantum world delights in laughing at that notion. You drift deeper into the lab, glancing at glass tubes and coils of wire, each a silent witness to experiments designed to answer one simple question: does the particle remember? And here's the cosmic joke: we humans struggle to remember why we just walked into the kitchen. Yet we're convinced we can figure out whether an electron remembers passing through one slit or two. The universe, it seems, has a wicked sense of humor. Einstein might have chuckled at that thought, then frowned, because for him, this wasn't just a physics problem, it was a question of whether reality makes sense at all. Floating there, you realize how profound the question truly is. If particles remember, then perhaps the universe is deterministic, with every event tied to a precise history. If they don't, then we're adrift in a sea of probabilities, where even the past can be rewritten by choices we haven't made yet. So tonight, as you lie under your blanket, remember, the story of particle memory isn't just about tiny specks of matter. It's about the nature of reality itself and how the universe might be far stranger than any bedtime story you've ever heard. And next time someone catches you staring off into space, just sigh and say, "I'm pondering whether particles remember where they've been." It'll either earn you instant respect or ensure you get the entire couch to yourself. Either way, it's a win. You're still floating in the quiet shadows of Einstein's laboratory when a narrow beam of light flickers to life across the room, spilling through a pair of razor-thin slits carved into a metal plate. Because tonight, you're going to witness one of the most mind-bending magic tricks in all of physics, a simple experiment that might hold the answer to whether particles remember the paths they've traveled. Your eyes lock onto the pale glow shimmering beyond those slits as tiny particles fins. Electrons, whatever you choose, began firing toward the barrier. One by one, they hit a screen behind it, each rival a soft, silent tap. But then something unexpected begins to happen. Mainstream fact, the double-slit experiment, first demonstrated by Thomas Young in the early 1800s and perfected with single particles in the 20th century, shows that particles like electrons and photons can create interference patterns, a set of alternating light and dark bands when not observed passing through the slits. It's as if each particle travels through both slits at once, behaving like a wave and interfering with itself. Quirky Einstein tidbit: despite being one of the giants who shaped quantum theory, Einstein always felt uneasy with the idea that particles could act like waves and vice versa. Physicists still argue whether Einstein's discomfort was the mark of brilliant skepticism or whether he simply couldn't accept that the universe might enjoy messing with our intuitions. Either way, he famously said, "God does not play dice," though the double-slit experiment seems determined to prove otherwise. Hovering near the beam of light, you watch as individual particles make dots on the screen. If you fire them one at a time, you'd expect simple clusters of dots, matching the positions of the two slits. But no. Instead, the dots gradually assemble into a delicate pattern of stripes, telltale sign of interference. Physicists still debate whether the interference pattern truly means a particle goes through both slits at once, or whether it's just a statistical effect describing many trials. Some interpretations say the particle travels all possible paths simultaneously until observed. Others insist there's a hidden mechanism that determines the outcome of it one we're forbidden to glimpse. The arguments rage on in conferences, papers, and coffee-fueled midnight discussions. Einstein's violin seems to hum softly from its dusty corner. You imagine him watching these experiments, bow poised in midair, refusing to accept that a single particle can split itself. Like a violinist playing two notes at once on separate strings, you lean closer to the glowing screen, hypnotized by the pattern slowly emerging. Each particle leaves only one mark, yet collectively, they build a ghostly lattice of light and shadow, a cosmic barcode revealing something fundamentally weird. Here's the cosmic joke. The experiment is absurdly simple. A light, two slits, a screen. It could be assembled in a high school lab. Yet it produces a result so unsettling that it's been called the single greatest mystery in physics. And then comes the real kicker when you try to watch which slit the particle goes through. The interference pattern disappears. The act of measuring seems to force the particle to choose a path, and it's as if the particle's memory of going through both slits at once has been erased. Physicists still debate whether this which path knowledge genuinely destroys a particle's interference, whether it's our knowledge alone that changes the outcome. Does nature fundamentally change under observation, or are we simply revealing an already fixed truth? It's a question that still sparks heated arguments, sometimes spilling over into the realm of philosophy. Hovering closer, you can almost hear the particles whispering secrets as they slip through the slits. Do they remember the alternate paths they could have taken? Or does each dot on the screen emerge fresh and memoryless, a singular outcome, with no echoes of what might have been? Einstein might have furrowed his brow, muttering that nature shouldn't be so mysterious. And yet, here you are, face to face with an experiment that refuses to explain itself in classical terms. So tonight, as you lie under your blanket, remember the humble double-slit experiment is more than a physics demo. It's a keyhole into a universe where particles might or might not tremble their own paths. And next time someone calls physics boring, just grin and say, "Really? Because I know an experiment that makes particles look like they're keeping secrets." That should be enough to spark some curious stares or get you swiftly uninvited from the next dinner party. You're still floating in that dim laboratory, the echoes of ghostly interference patterns lingering in the air, when a familiar presence seems to drift in beside you, a man with a halo of wild hair, sweater sleeves pushed up, chalk dust on his trousers. Because tonight, you're going to witness how Einstein himself tangled with the notion that particles might remember or forget their past, and why that question gnawed at him like an itch he could never quite scratch. Einstein stands by the blackboard, staring at the double-slit diagram sketched in firm white lines. His eyes narrow, as if daring the chalk marks to explain themselves. Mainstream fact. Despite contributing foundational ideas to quantum theory, including explaining the photoelectric effect and introducing the concept of photons, Einstein famously distrusted quantum mechanics' probabilistic nature. He wanted a universe in which particles had definite properties and paths, even if we couldn't always see them. Quirky Einstein tidbit. While he might have been battling the uncertainty of quantum theory, Einstein was certain about one thing: his love for pipe smoking. He claimed it contributed to a calm and objective judgment in all human affairs. Physicists still argue whether this was true insight or simply a convenient excuse for an epic smoking habit. Either way, his pipe became nearly as iconic as his hair. Hovering close, you watch Einstein draw a neat question mark beside his sketch of the double slits. He steps back, arms crossed, frowning. To him, the idea that a particle could travel both paths and somehow forget its own history if measured was absurd. Physicists still debate whether Einstein's resistance to quantum weirdness was a flaw or a feature of his genius. Some say his stubbornness held physics back from accepting quantum reality. Others argue that his relentless skepticism has driven generations of scientists to keep probing the depths of quantum mysteries. The debate smolders on, like the embers in Einstein's perpetually glowing pipe. Einstein's violin leans in the corner, silent but watchful, as though waiting to soothe his tangled thoughts. You imagine him putting down the chalk, picking up the violin, and playing a few trembling bars of Mozart to calm his mind. Einstein believed the universe should be logical and predictable. Even when he accepted that we might not know a particle's exact path, he insisted the particle still had one. God does not play dice, he grumbled to anyone who would listen. The notion that observation could erase a particle's memory of its path felt like cosmic betrayal. Hovering beside him, you sense the weight of his frustration, because the double-slit experiment seemed to say the particle only decides where it's been. Once we choose to look, it's as if the past is written retroactively, depending on the questions we ask in the present. Physicists still debate whether reality is genuinely indeterminate until measured, or whether hidden variables and confound factors buried deep within particles are guiding outcomes all along. Is uncertainty a property of nature itself, or merely of our ignorance? It's a question that loops back to whether particles truly have memories of their past trajectories. Einstein's voice drifts into your mind. You hear him insisting that every particle must have a definite history, even if it's hidden from us. He couldn't accept a universe where a photon drifts through both slits, only choosing a path once we peak. And here's your cosmic joke. Einstein, who resisted randomness in physics, loved games of chance in his private life. He enjoyed sailing, despite his legendary absent-mindedness, and even played the violin at friends' poker nights. It's a bit ironic that the man who didn't want God playing dice was perfectly fine with humans doing it for fun. Floating above the chalkboard, you glimpse the lingering tension between Einstein's craving for simplicity and quantum mechanics' embrace of probability. His resistance wasn't merely intellectual, it was emotional. For him, a universe that couldn't remember its own past felt incomplete, even insulting. Einstein's violin glimmers softly, as though offering a counterpoint to his cosmic frustration. Maybe music was his way of imposing order on a universe he feared might be fundamentally chaotic. So tonight, as you lie under your blanket, remember, Einstein's discomfort with quantum mysteries wasn't just stubbornness. It was a deep conviction that the universe should remember its own story. And the fact that we still don't know if particles truly have paths or memories means that, even now, we're living inside Einstein's lingering question mark. And next time someone accuses you of being stubborn, just lift your chin and say, "I'm merely channeling my inner Einstein." Then casually mention you're pondering whether particles remember where they've been. That should either spark fascinating conversation or ensure you get the couch all to yourself. You're still drifting beside Einstein, the scent of chalk dust and faint pipe smoke lingering in the lab's cool air, when a sudden bright gleam flashes across his eyes. Because tonight, you're going to witness how the double-slit experiment takes an even stranger turn, a twist that hinges on one simple question: can you resist the temptation to look? Einstein stands, arms folded, glaring at a sketch of the double slits, and in that glare is the same stubborn question that has haunted physicists for decades. What really happens when you try to find out which path the particle takes? Mainstream fact, in the double-slit experiment, as long as no measurement is made to detect which slit the particle passes through, an interference pattern appears on the screen, revealing its wave-like behavior. But the moment you place a detector to measure which path information, the interference pattern disappears, and the particle behaves like a classical object traveling through one slit or the other. Quirky Einstein tidbit: despite obsessing over cosmic mysteries, Einstein sometimes entertained visitors by performing little magic tricks with coins and cards. Physicists still argue whether this was just friendly fun or a sly commentary on how observation itself alters outcomes, just like in quantum mechanics. Either way, it's comforting to imagine him as both a genius and a bit of a party magician. Hovering close, you watch him tap his chalk against the board. He sketches a tiny divisha, which path detector hovering just behind one of the slits. It's a simple idea. Find out which slit the particle goes through, solve the mystery. Put Einstein's mind at ease. Except that's not what happens. Physicists still debate whether the disappearance of interference, when measuring which path information, proves that observation collapses a particle's wave function or whether it merely reflects how measurement destroys the delicate phase relationships needed for interference. Is consciousness required to cause this collapse, or is it purely a mechanical process? The debate continues like an endless ping-pong match in quantum physics seminars. Einstein's violin leans against the wall, its strings seemingly silent witnesses to this quantum conundrum. You imagine him turning away from the blackboard to pick up his violin and play a few frustrated bars, hoping the music will untangle the universe's stubborn secrets. The weirdest part is how simply the effect works. Set up your slits. Let particles fly through one at a time. Keep your detectors turned off and behold, interference emerges. As if the particles wander through both slits and somehow remember the possibilities they explored. But switch on the detectors, and suddenly, the interference vanishes. The particles choose a single slit, and the pattern on the screen collapses into two bland clusters. It's as though the particles whisper, "If you're going to watch me, I'll behave like a polite little ball instead of a rebellious wave." Here's the cosmic joke. Physicists have rigged which path detectors so sensitive that they barely interact with the particlesiate. Even the slightest hint of measuring still wipes out the interference pattern. The particles act like they know we're trying to spy on them. It's enough to make you wonder whether electrons should come with privacy policies. Hovering closer, you glimpse the heart of Einstein's dilemma. He couldn't accept that simply trying to peek could fundamentally alter reality. It's as if the act of asking the question changes the answer and maybe even erases the particle's memory of traveling multiple paths. Physicists still debate whether particles truly decide on a path during measurement, or whether all possible paths remain real in separate branches of the universe. As the many-worlds interpretation suggests, does observation collapse possibilities into one reality or merely reveal which branch of the cosmic tree you're now inhabiting? The argument glows red-hot in physics circles, where people argue passionately about particles' secret histories. Einstein once muttered that it was like the moon disappearing if you stopped looking at ita notion. He found absurd, and yet the which path dilemma refuses to go away. You drift closer as Einstein frowns at his chalk diagram, tracing lines from each slit to the screen. He seems desperate for a simpler answer, one where particles travel one path, remember where they've been, and don't alter reality based on human curiosity. But quantum mechanics offers no comfort. Instead, it suggests that memory itself might be contingent. A particle's knowledge of its path can vanish the instant you choose to look or not look. Einstein's violin flickers in the shadows, as if daring the universe to explain itself in melody instead of math. So tonight, as you lie under your blanket, remember, in the quantum world, even the act of looking changes what's true and perhaps wipes away the particle's memory of its own journey. And next time someone catches you daydreaming and asks, "What are you thinking about?" just sigh and say, "I'm wondering whether electrons have privacy rights." That should either earn you a friend for Liffey or the entire elevator ride in perfect silence. Either way, mission accomplished. You're still hovering beside Einstein, the faint glow of chalk dust hanging in the quiet lab air. When the clock on the wall seems to stutter, as though time itself is catching its breath. Because tonight, you're going to slip into one of the strangest corridors of quantum thought, a place where the future might rewrite the past, and where particles seem to wait for us to make up our minds. Einstein stands, arms crossed, glaring at a diagram on the blackboard as though it has personally offended him. He's muttering under his breath about logic, sanity, and how the universe has no business behaving like a cosmic stage magician. Mainstream fact: delayed choice experiments, first proposed by John Archibald Wheeler, test whether a particle decides how to behave like a wave, or a particle depending on measurements made after it has already passed through an apparatus. It's as if the experimenter's future choice determines the particle's past behavior. Quirky Einstein tidbit: Einstein was famously suspicious of any physics, suggesting time could play tricks. Yet he once quipped that time is merely a stubbornly persistent illusion, which physicists still argue over to this day. Did he mean it poetically? Or was he hinting that time itself might be more flexible than we believe? Either way, it's one of science's most deliciously confusing sound bites. Hovering closer, you watch Einstein rub his temples. Delayed choice experiments sound innocent enough. Let a photon fly toward a double slit. Decide ladder after the photon has passed the slits whether to observe which path it took, or whether to preserve the interference pattern. And here's the kicker: depending on your last-minute decision, the photon seems to retroactively behave as though it either took one path or both, as though it's waiting to find out how you plan to test it before deciding where it's been. Physicists still debate whether delayed choice experiments truly imply retrocausality. Future decisions can alter the past, or whether the outcomes simply reflect correlations baked into the fabric of quantum mechanics. Is the past malleable, or are we misreading the experiment's strange logic? Conferences buzz with physicists passionately defending both sides, occasionally with enough caffeine to power a particle accelerator. Einstein's violin leans against the wall, its strings silent, as though refusing to play until the universe explains itself. Floating beside Einstein, you hear him grumble that physics has no business entertaining such nonsense to him. Reality should be firmly rooted in cause and effect. The idea that a measurement made now could change what happened earlier was, to him, cosmic heresy. Yet delayed choice experiments keep delivering results that are hard to explain any other way. They suggest the particle's history, whether it remembers going through one slit, or both, depends on measurements performed after the fact. Here's your cosmic joke: humans can barely remember where we put our car keys 5 minutes ago. Meanwhile, quantum particles are out here rewriting their own pasts depending on choices we haven't even made. Yet, the universe definitely has a sense of humor. Hovering closer, you feel the chill of possibility ripple through the lab. If the future can influence the past, even sublithium time might not be the rigid one-way street we imagine. Instead, it could be a flexible fabric where memory and causality blur into one another. Physicists still debate whether delayed choice experiments require new physics, or if they're just strange, but ultimately harmless illusions of interpretation. Some insist everything remains perfectly logical if we frame the math correctly. Others argue that our intuitions about time and memory might be fundamentally wrong. Einstein glares at his chalk diagram, as if hoping sheer stubbornness might force the universe to behave sensibly. But you know he's wrestling with a terrifying thought. If particles can wait for us to decide whether to look, then what does memory mean for a particle? Can it truly remember its path, or is its entire past rewritten in the instant we choose to observe? Einstein's violin flickers in the shadows, as though plucking a cautious note, uncertain whether it should play forward or backward in time. So tonight, as you lie under your blanket, remember, in the quantum realm, the past might not be set in stone. It might depend on questions we haven't even asked yet, and on whether particles remember their own journeys. And next time someone complains that physics is too theoretical, just grin and say, "I'm trying to decide if the past is real or optional." That should either earn you a new friend or guarantee you the entire bench at the bus stop. Either way, it's worth it. You're still gliding beside Einstein, the chalkboard filled with squiggly lines that seem to twist both forward and backward through time, when the lab's shadows suddenly feel deeper, as though secrets are coiling there, waiting. Because tonight, you're going to slip into one of the strangest experimental games ever devised. the quantum erasera trick that asks whether particles can have their past erased, and if erasing information brings back forgotten memories of their hidden paths. Einstein is pacing again, pipe smoke swirling around him like a private nebula. He mutters under his breath about logic and sanity, and for once, even the violin in the corner looks nervous. Mainstream fact: quantum eraser experiments show that if you erase the witch path information about a particle after it's passed through the slits bit, before final detection, the interference pattern can be restored. It's as if the universe forgives your curiosity and lets the particle go back to behaving like a wave. Quirky Einstein tidbit: though Einstein's papers are famous for reshaping physics, he also loved cracking practical jokes. He'd hand people sealed envelopes labeled Top Secret Theory, which when opened, contained goofy cartoons or nonsense equations. Physicists still debate whether this was a sign of genius-level humor, a cosmic-level attempt to stay sane while the universe refused to explain itself. Either way, it's delightfully human. Hovering closer, you watch Einstein scribble diagrams showing light beams splitting and rejoining, mirrors gleaming, detectors waiting like paparazzi hiding in cosmic bushes. The quantum eraser sounds like a conjuring trick because, in many ways, it is. Physicists still debate whether quantum eraser experiments genuinely prove retrocausally that future actions can alter the past or whether they merely reflect our incomplete understanding of entanglement and measurement. Does erasing witch path info change the past, or just change our knowledge of it? The debate crackles through journals and conferences like static over an old radio. Einstein's violin leans in its corner, as though straining to hear whether time has begun running in reverse. Picture this: photons stream toward a double slit, somewhere downstream. A clever optical setup records which slit each photon went through. Under normal circumstances, this destroys the interference pattern. The particles remember their path, the past is fixed. But here's where the magic happens. Before the final detection, the witch path info is erased, the data is jumbled or lost in a way that makes it impossible to know which slit the photon chose. And suddenly, the interference pattern reappears. It's as if the particle's earlier journey through one slighter buff depends on whether its history is preserved or deleted. Here's your cosmic joke: we live in a world where deleting your browser history can't truly erase your secrets. But quantum particles apparently get to have their entire past wiped clean. If the universe decides to hit the cosmic delete key, somewhere, the electrons are laughing at us. Hovering beside Einstein, you sense his discomfort. For him, the idea that forgetting which path a particle took could change reality was unbearable. The notion that particles might have a kind of selective memory and that we can tinker with it after the fact was an affront to the clear, orderly cosmos he believed in. Physicists still debate whether the quantum eraser shows that reality itself changes or simply that probabilities rearrange based on what information exists. Is the particle's memory real, or is it just an illusion created by our measurement choices? The question ripples through the field, keeping both experimentalists and theorists awake at night. Einstein's violin quivers faintly, perhaps imagining itself playing a piece backward if the quantum eraser demands it. You float closer as Einstein sketches equations with increasing frustration. He can't accept that a particle's past can be unwritten. To him, that's like suggesting a symphony could unplay itself once the audience leaves the concert hall. Yet the experiments persist in whispering that reality might be flexible. Erase the path info, and the particle acts like it never chose a slit at all. Keep the info, and it locks itself into a single history. It's as though particles decide whether to remember their path, depending on whether we keep the evidence. Einstein's violin glints in the lamplight, perhaps daring the universe to explain itself through music instead of math. So tonight, as you lie under your blanket, remember the quantum eraser isn't just a physics trick, it's a cosmic riddle about memory, choice, and whether the past is as stable as we like to believe. And next time someone tells you they're deleting their old text messages, just raise an eyebrow and say, "Careful, quantum particles might be taking notes." That should either win you admiration or ensure you dine alone in perfect, philosophical peace. You're still hovering in the soft shadows of Einstein's lab, the scent of pipe smoke and chalk dust curling around you like gentle spirals of cosmic mystery. when a pair of particles appear, seemingly connected by an invisible thread. Because tonight, you're going to witness how quantum entanglement, infamous spooky action at a distance, dives into the question of memory and whether particles can share secrets about the paths they've traveled. Einstein leans over the blackboard, his hair looking even wilder than usual, muttering in German as he sketches two dots connected by a zigzagging line. His chalk squeaks sharply, like the quantum realm itself protesting the intrusion. Mainstream fact: quantum entanglement occurs when two or more particles become linked in such a way that the state of one instantaneously affects the state of the other. No matter how far apart they are, measure one, and the other knows what result to produce, even across cosmic distances. Quirky Einstein tidbit: despite the seriousness of his physics, Einstein loved jokes and puns. He even enjoyed writing humorous poems in letters to friends. Physicists still debate whether his sense of humor helped him cope with the universe's insanity, or if it simply added to the confusion. Either way, it's comforting to know the man behind the equations was also ready with a good punchline. Hovering closer, you watch him jab the chalk toward the zigzag line. To Einstein, entanglement was an affront to everything sensible. He dubbed it spooky action at a distance, as if the universe were pulling cosmic pranks. Physicists still debate whether entanglement implies genuine faster-than-light communication, or whether it merely reflects deep correlations that don't transmit usable information. Is the universe secretly gossiping between particles, or are we just witnessing statistical magic? The debate hums like an electric violin across physics departments worldwide. Einstein's violin leans in its corner, silent yet somehow radiating disapproval, as though it too can't decide whether to believe in spooky connections. Imagine two particles created in the same event, zooming off in opposite directions. You measure one's spin and instantly know the spin of the other, even if it's light years away. It's as though they're exchanging cosmic text messages faster than physics says should be possible. Here's your cosmic joke: humans can't keep secrets across a dinner table without someone spilling the beans. But quantum particles apparently share secrets across the galaxy, without anyone being able to intercept the messages. Nature clearly knows how to keep things hush-hush. Hovering near Einstein, you feel his frustration. He couldn't accept that particles could remain connected without some hidden mechanism explaining it. He believed entanglement must involve secret variables, tiny gears turning unseen to preserve local realism and keep physics comfortably non-mysterious. But modern experiments keep proving otherwise, no matter how carefully scientists test them. Entangled particles keep behaving as if they're sharing knowledge instantaneously. And it raises a tantalizing question: do particles remember the conditions under which they became entangled? Is their shared state a kind of cosmic memory, binding their fates even when separated by vast distances? Physicists still debate whether entanglement means particles maintain a memory of past interactions, or whether their connection transcends time and space altogether. Are we dealing with stored information, or is entanglement simply the nature of reality itself? The arguments ripple through journals and lectures, leaving everyone's heads spinning. Einstein's violin gleams under the lab lights. You imagine it playing to notes perfectly in sync across two distant rooms, an eerie echo of entanglement's reach. Hovering closer, you watch Einstein shake his head, muttering that reality shouldn't be this messy. For him, the idea that measuring one particle instantly affects another no matter how far apart was intolerable. Yet the experiments stubbornly refused to align with classical intuition. And here's the cosmic joke: while Einstein fought against the weirdness of entanglement, he unknowingly helped lay the groundwork for quantum technologies like teleportation, quantum encryption, and ultra-fast computing. The very thing he resisted may yet transform our future. Einstein's violin seems to shiver, as though aware that the universe might indeed be whispering secrets across light years. So tonight, as you lie under your blanket, remember, entanglement isn't just spooky action. It's a question about memory, connection, and whether particles might be keeping cosmic diaries of where they've been and who they're forever linked to. And next time someone rolls their eyes and says physics is dry, just grin and say, actually, it's full of gossiping particles and secret cosmic friendships. That should either earn you a fascinating conversation or get you swiftly labeled the eccentric genius of your social circle. Either way, Einstein would approve. You're still drifting beside Einstein, the phantom glow of entangled particles fading around you. When the ticking of a clock echoes through the lab like distant footsteps in a dark hallway. Because tonight, you're going to probe the deepest connection of all between time, memory, and whether particles can remember their pasts, or if memory itself might be just an illusion, woven into the cosmic fabric by our human minds. Einstein stands motionless, gazing at a pocket watch he's pulled from his rumpled sweater. The metal glints under the lamp, its second hand sweeping forward with relentless certainty. Yet behind his eyes, you sense the same cosmic mischief that whispers, what if time isn't quite what we think? Mainstream fact, time's arrow. The idea that time moves only forward is tied to entropy, the universal tendency for disorder to increase. In physics, the laws governing fundamental particles are mostly time-symmetric. They don't care whether time moves forward or backward. Yet we experience time as flowing in one direction, from past to future. Quirky Einstein tidbit: despite pondering time's mysteries, Einstein himself was notoriously bad at keeping track of it in everyday life. He'd often lose hours to thought experiments, emerging dazed and blinking like someone stepping out of a time machine. Physicists still debate whether that was the price of genius or merely the side effect of refusing to wear a wristwatch. Either way, it's a comfort to those of us who've missed more than a few appointments. Hovering close, you watch him close the pocket watch with a click. For Einstein, time wasn't merely hours ticking by, it was a dimension, as real as length, width, and height. But the question remains, if the laws of physics don't care about time's direction, do particles carry memories of the past? Or is memory simply the story we tell ourselves to make sense of events happening in a universe that might be timeless underneath? Physicists still debate whether the apparent flow of time is real or simply an emergent property of our consciousness. Is time a fundamental feature of the universe, or merely a trick played by the human brain interpreting sequences of cause and effect? The argument flows like liquid mercury through physics conferences, fascinating and impossible to hold in one place. Einstein's violin waits in the corner, strings silent as though pondering whether music itself would sound the same played backward. You hover closer as Einstein sketches two clocks on his blackboard-owned stationery, one zooming through space. Relativity tells us they tick differently depending on speed and gravity. Time stretches, contracts, and refuses to behave like a universal rhythm. Here's your cosmic joke. The same man who discovered time dilation once wandered out of his office, so engrossed in thought that he forgot he'd left his coffee boiling over a Bunsen burner. Turns out, the arrow of time still matters when your lab smells like scorched espresso. Hovering above the blackboard, you realize this time puzzle connects directly to memory. In the macroscopic world, memory is built on the asymmetry of time. We remember the past because it's fixed and irreversible. But in the quantum world, events often remain reversible until measured. Physicists still debate whether particles carry any memory of the paths they've traveled. Are they following definite tracks through spacetime, each moment leaving a mark behind? Or does the universe store no history at all, with particles existing only in the eternal now until we force them into a definite state? Einstein frowns at the chalk in his hand, visibly annoyed. He once remarked that the distinction between past, present, and future is merely a stubbornly persistent illusion. Yet he couldn't quite accept that particles might lack any true memory of their own trajectories. Einstein's violin gleams under the lamp, as though daring the universe to prove whether time's melody can really run in reverse. Hovering closer, you imagine time not as a single river flowing forward, but as a vast ocean where all moments coexist. In such a universe, perhaps particles don't remember their paths, because there's no need to. Every possibility is eternally present. And here's the cosmic joke. While Einstein sought certainty, time keeps slipping away. Both in the lab and in life, humans cling to memories as anchors, but the universe seems entirely indifferent. So tonight, as you lie under your blanket, remember the mystery of whether particles remember their past paths is deeply tied to time itself. And time, it seems, remains the universe's most elusive prank. And next time someone asks why you're staring at the clock with a haunted expression, Just sigh and say, "I'm wondering whether time is real or whether particles remember yesterday." That should either spark a conversation or guarantee you a solo commute on the subway. Either way, it's worth it. You're still drifting beside Einstein, the ticking of clocks fading into a soft cosmic hush, when he suddenly turns back to the blackboard, eyes blazing with determination. Because tonight, you're going to see how Einstein refused to surrender to quantum weirdness and why he clung so fiercely to the belief that particles have definite paths, perhaps hidden from us, and maybe even carrying memories we can't yet detect. Einstein's fingers grip a piece of chalk so tightly it nearly snaps. He scribbles furious equations, then erases them just as quickly, as if hoping that somewhere in the dust lies the key to the universe's secrets. Mainstream fact: in the 1920s and 30s, Einstein challenged the mainstream interpretation of quantum mechanics, proposing that so-called hidden variables might exist beneath quantum uncertainty. These hypothetical variables would restore determinism and imply particles do indeed have definite properties and trajectories, even if we can't observe them directly. Quirky Einstein tidbit: despite his cosmic genius, Einstein never bothered to learn how to drive. He preferred walking everywhere, letting his thoughts roam free. Physicists still debate whether his refusal to get behind the wheel was a protest against earthly complexities or simply a practical decision to avoid distracting traffic while contemplating the curvature of spacetime. Either way, it's delightfully fitting. Hovering close, you watch him draw a diagram of the slits again, but this time, he adds tiny arrows looping around each particle's path. He's convinced those arrows exist, invisible but real, like secret footprints left in cosmic sand. Physicists still debate whether hidden variables truly exist or whether quantum randomness is fundamental. The famous Bell's theorem, formulated in the 1960s, placed powerful constraints on hidden variable theories, suggesting that no local hidden variables can fully explain quantum entanglement's predictions. Yet some physicists remain determined to uncover deeper mechanisms. The debate continues like a cosmic ping-pong match, bouncing between determinism and pure chance. Einstein's violin rests nearby, silent, but glimmering in the lamplight. You imagine its strings quivering, ready to play a melody woven from hidden truths. Einstein couldn't accept that particles simply decide their fate when observed. He believed the moon remains in the sky whether we look at it or noting that particles, too, must have definite paths, and perhaps memories of those paths, written in hidden variables we just haven't found. Here's your cosmic joke. The same Einstein who demanded hidden order in the quantum realm couldn't be bothered to carry an ID card. He once had to convince a hotel clerk he was Einstein by writing down E=mc on a scrap of paper. Turns out even cosmic geniuses need credentials sometimes. Hovering closer, you sense his frustration. Hidden variables offered him a comforting alternative. Maybe particles remember their paths, and quantum uncertainty is simply our ignorance of the true details. If only we could peek beneath the surface, we'd find the universe as logical and deterministic as ever. Physicists still debate whether Einstein's faith in hidden variables was prophetic or misplaced. Some modern approaches, like Bohmian mechanics, keep the idea alive, proposing that particles do follow specific paths, guided by hidden pilot waves. Others argue that the universe simply doesn't work that way, that uncertainty is built into the bedrock of reality. Einstein's violin glimmers again, as if daring him to try playing a secret note that only hidden variables would hear. Hovering above his chalkboard, you watch him shake his head, muttering about how God surely doesn't play dice with the cosmos. For him, hidden variables weren't merely a technical fix, they were a lifeline back to a universe that remembers its own history, where particles leave footprints, however faint. And here's another cosmic joke. While Einstein hoped for hidden certainty, he was famous for leaving half-finished notes scattered around his study. Tiny mysteries with no context. Somewhere in those scraps, perhaps, lay his own hidden variables waiting to be decoded. Einstein's violin sits patiently in its corner, as though waiting for him to admit that sometimes even music finds beauty in uncertainty. So tonight, as you lie under your blanket, remember, Einstein's hidden variables were more than a scientific idea. They were his declaration that the universe must remember itself, that particles Don't just drift aimlessly through endless possibilities, but carry with them a secret story we've yet to fully read. And next time someone tells you life is all random, just smile and say, well, Einstein thought there might be hidden variables keeping track of everything. Then watch as they either nod sagely or slowly inch away. Either way, Einstein would approve. You're still hovering beside Einstein, chalk dust twinkling like microscopic stars in the glow of his study lamp, when a stack of recent journals catches your eye. Because tonight, you're going to peek into the 21st century, where physicists keep poking and prodding reality with experiments more precise and more mind-bending than anything Einstein could have imagined. All in pursuit of one lingering question: can particles remember the paths they've traveled? Einstein stands by the cluttered desk, his bushy eyebrows lifted as he rifles through a pile of modern physics papers. Though he's technically a man out of time, he can't resist checking whether the universe has finally agreed to make sense. Mainstream fact: modern experiments, including increasingly sophisticated versions of the double slit and Bell tests, have confirmed quantum predictions with astonishing precision. Experiments keep showing that particles do not reveal definite paths unless measured, and that entangled particles behave in ways that defy classical logic. No hidden variables have yet fully explained these results under local realism. Quirky Einstein tidbit: despite pioneering physics revolutions, Einstein occasionally lost patience with modern gadgets. He once joked about not needing a telephone, because if people wanted to reach him, they'd find him. Physicists still debate whether that's profound simplicity or just an elegant excuse for dodging unwanted calls. Either way, it's kind of genius. Hovering close, you watch Einstein peer at an article detailing single-photon interference experiments. Modern technology now sends individual photons through complex apparatuses, testing whether their paths leave any traceable history. Physicists still debate whether the results imply particles truly lack paths, or whether subtler forms of hidden information might be encoded in ways we can't yet detect. Are particles genuinely memoryless, or are we simply asking the wrong questions? Conferences buzz with passionate debates, coffee cups shaking as physicists gesture wildly about probability amplitudes. Einstein's violin remains silent in its corner, perhaps sulking because modern experiments have gotten too technical for sheet music. Consider ultrasensitive detectors measuring single electrons passing through slits one at a time. The interference patterns still emerge, hinting that particles might not choose a path until observed. Yet even in the 21st century, no experiment has proven that particles remember or forget their journeys in a way Einstein would find satisfactory. Here's your cosmic joke: we humans can't remember where we left our keys 5 minutes ago, but physicists are determined to prove whether a photon remembers the path it took through a nanoscopic crystal. Priorities, right? Hovering closer, you glimpse experiments involving trapped ions, superconducting circuits, and quantum dots trying to pin down whether particles leave any hidden footprints of their paths. Some researchers propose that memory-like information could be preserved in subtle correlations, even if individual particles appear memoryless. Physicists still debate whether the universe's refusal to reveal paths indicates fundamental indeterminacy or whether a deeper, unified theory remains undiscovered. Are particles simply obeying the math of quantum mechanics, or do they hide secrets waiting for future experiments to uncover? The question hovers over the field like a particle in a superposition. Einstein flips through another paper, frowning. You can almost hear him muttering that no matter how fancy our lasers get, the universe should behave rationally. He'd probably be both awed and exasperated by experiments involving quantum computers, where qubits remain in strange superpositions, refusing to declare their states until measured. And here's another cosmic joke: while physicists spend billions building machines to measure particles' secrets, some experiments boil down to asking electrons politely whether they'd care to reveal their private business. Spoiler alert, they rarely do. Einstein's violin shimmers under the lamplight, as though sighing that music, at least, doesn't argue about hidden variables. Hovering beside him, you feel the modern urgency in physics. Technology has given us tools of staggering precision, yet the same old questions remain. Do particles have definite paths? Do they remember those paths? Or is memory itself an illusion projected by our classical brains onto a quantum reality that simply refuses to care? Einstein puts the papers down, running a hand through his wild hair. He can't help but smile, because even if he disagrees with the answers, he'd appreciate that people are still chasing the same mysteries that kept him awake at night. So tonight, as you lie under your blanket, remember, even with all our modern experiments, we still don't know whether particles remember where they've been. And the more precisely we look, the more the universe seems to dodge the question. And next time someone asks what modern science is good for, just grin and say, it's trying to discover whether the universe is keeping secrets from itself. That should either earn you a weir and ensure you get the window seat on your next flight. Either way, mission accomplished. You're still hovering beside Einstein. Stacks of modern physics journals rustling in the faint breeze of the lab, when the atmosphere seems to grow dense with a strange, hushed anticipation. Because tonight, you're going to peer into one of the most controversial and wildly entertaining questions, sparked by the mysteries of quantum mechanics. Could particles actually possess some primitive form of consciousness, or at least know what's happening around them? Einstein tilts his head and squints at you, as though trying to decide whether to lecture you for cosmic blasphemy or pour you a cup of coffee for your troubles. Mainstream fact, the notion that particles know which path they took, comes from how their behavior appears to change depending on whether we measure certain properties. In quantum mechanics, particles sometimes act as if they're aware of experimental setups, a phenomenon that fuels speculation about their awareness of being watched. Quirky Einstein tidbit: despite grappling with weighty philosophical questions, Einstein kept a playful side. He was known to slip out of meetings to go for solitary walks, sometimes leaving colleagues mid-sentence. Physicists still debate whether this was a sign of deep contemplation or just tactical genius for avoiding tedious committee discussions. Either way, the man understood his own mental bandwidth. Hovering closer, you see him raise an eyebrow. He's heard the whispers in physics circles. The question goes something like this: if particles alter their behavior when measured, does that mean they somehow know they're being watched? Could particles hold information not just about physical states, but about decisions and context? Physicists still debate whether this idea crosses the line from physics into mystical nonsense. Some argue it's merely metaphor, that speaking of particles knowing anything is anthropomorphism, projecting human concepts onto mindless quantum systems. Others wonder whether consciousness might emerge from quantum processes themselves, or whether particles contain the seeds of awareness, however primitive. The arguments rage on, equal parts thrilling and exasperating. Einstein's violin waits quietly in its corner, as though pondering whether to join the discussion or remain blissfully ignorant of quantum philosophy. Hovering above the chalkboard, you hear Einstein mutter that consciousness has no business lurking inside electrons for him. The idea that inanimate particles could know anything was absurd. He preferred a clear, mechanical universe, even if it hid secrets and hidden variables rather than self-aware quarks. And yet, here's the cosmic joke. Physicists routinely say things like, the particle decides which slit it went through, or the electron knows it's being observed. Language itself betrays how tempted we are to attribute agency and memory to the quantum realm. Hovering closer, you recall how some physicists propose that consciousness might play a role in collapsing the wave function, that without an observer, reality remains suspended in endless possibilities. It's a notion that both fascinates and horrifies scientists, sparking debates that occasionally veer into metaphysics and philosophy. Physicists still debate whether consciousness collapses wave functions or whether collapse is purely a physical process. Some theories even hint that particles might contain proto-consciousness, a minimal form of awareness or information processing capacity that scales up to human thought in complex systems. Einstein, of course, rejected such ideas with characteristic bluntness. He believed physics should describe objective reality, not blurry metaphysical concepts. To him, the universe might be mysterious, but it didn't harbor little minds inside photons. Einstein's violin glimmers faintly, perhaps suggesting that music, at least, knows how to express mysteries without demanding that particles develop opinions. And here's another cosmic joke. While Einstein resisted the notion of particle consciousness, He spent a lifetime pondering the role of the observer in physics. His discomfort with quantum indeterminacy was partly because it seemed to demand that the universe care whether humans were watching, a concept he found laughable and deeply troubling all at once. Hovering above his chalkboard, you realize how much the question of particle memory overlaps with the notion of awareness. If particles can remember their paths, is that a kind of knowledge? If they change behavior when watched, is that awareness or simply physics doing what physics does? Einstein would have insisted that these are linguistic traps, but you can't deny how the language of physics sometimes slips into conscious metaphors, hinting that reality might be stranger and perhaps more alive than we're comfortable admitting. So tonight, as you lie under your blanket, remember, the question of whether particles remember their paths veers dangerously close to asking whether the universe itself might be aware of its own existence. And while that's a rabbit hole even Einstein might not follow you down, it's a wonder worth pondering. And next time someone says you're overthinking things, just smile and whisper, "I'm trying to figure out if electrons are self-aware." That should either win you instant respect or ensure you dine alone in peaceful cosmic contemplation. Either way, Einstein would have been curious to hear your thoughts. You're still floating beside Einstein, the shadows of swirling equations dancing on the lab walls, when he finally sets down his chalk and gives you a long, measured look. Because tonight, you're going to bring this quantum journey full circle. Discover how the question of whether particles remember their past paths ties directly into something deeply human. The way we remember our own stories, make choices, and navigate the strange terrain of time. Einstein leans forward, resting his elbows on the cluttered desk, pipe smoldering quietly as though exhaling the last mysteries of the cosmos. Mainstream fact, in quantum mechanics, the idea of memory and path information sits at the heart of the measurement problem, and the wave function collapse. The question of whether particles remember or even possess definite paths relates closely to our human concepts of determinism, free will, and causality. Quirky Einstein tidbit: despite wrestling with cosmic truths, Einstein was a notorious doodler. Manuscripts and letters are peppered with little sketches of faces, boats, and abstract squiggles. Physicists still debate whether these were subconscious bursts of genius or simply evidence that even the world's greatest mind occasionally zoned out in meetings. Either way, it's a comforting reminder of his humanity. Hovering closer, you watch him tap ash from his pipe. He seems pensive, as though realizing that particles and people might share more in common than we'd ever expect. Physicists still debate whether the apparent randomness in quantum events is truly fundamental, or whether hidden variables or future discoveries will restore a deterministic universe. This debate mirrors philosophical battles about free will. Are we truly free to choose? Or are our lives guided by hidden forces, memories, and prior paths we can't escape? Einstein's violin glints gently under the lamp, as though longing to play a melody that connects the dance of atoms to the beat of human hearts. You hover beside him, thinking about how our own memories shape who we believe ourselves to be. We remember childhood moments, triumphs, embarrassments, heartbreaks. Each memory becomes a step along the path that leads us here. But quantum physics whispers that the universe may not work that way, that particles might not have definitive histories until forced to reveal one. Here's your cosmic joke. Humans spend entire lifetimes obsessing over the past, scrutinizing memories, regrets, what-ifs, while electrons might not even know they had a past until someone insists on measuring it. The universe's sense of irony is deliciously savage. Hovering closer, you sense Einstein wrestling with the same philosophical tangle. If particles don't have definite pasts, what does that mean for our sense of identity? Are our personal histories just narratives we tell ourselves, superimposed over a reality that might be timeless beneath the surface? Physicists still debate whether time itself is an emergent property arising from entanglement and correlations, or whether the past, present, and future all coexist. In such a reality, our memories might simply be snapshots our brains assemble from quantum data, giving us the illusion of moving forward along a definite path. Einstein sighs, as though even he can't quite solve this one. He believed deeply in an orderly universe, where paths exist, memories endure, and truth waits patiently to be discovered. Yet even he admitted that the distinction between past, present, and future is a stubbornly persistent illusion. Einstein's violin stirs in its corner, ready to offer a gentle coda to this cosmic riddle. Hovering above the desk, you realize the question of whether particles remember their paths is not just physics, it's the ultimate human question. We want to know that our choices matter, that our lives have continuity, that who we are today connects to who we were yesterday. Maybe the answer lies somewhere between. Perhaps the universe does remember, just not in the neat, linear way we do. Perhaps particles keep secrets in subtle correlations, just as we hold memories in hidden corners of our minds. So tonight, as you lie under your blanket, remember, the mystery of whether particles remember their paths is also about how we remember our own. It's about curiosity, wonder, and the eternal search for meaning in a universe that might be far stranger and more beautiful than we ever imagined. And next time someone asks why you look so thoughtful, just grin and say, "I'm pondering whether electrons have life stories." That should either earn you the best conversation of your life or a blissful moment of cosmic silence. Either way, Einstein would definitely approve.